In this video, we will determine the equation of two parabolas, also known as the quadratic function. In both examples, we'll find the equation of the quadratic function in its general form, which is fx equals to ax squared plus q. And what we want to find is an a value and a q value in order for us to write out the equation in standard form. So in our first example, we have a quadratic function or a parabola running through the y-intercept at 3, and also a point is given running through the coordinates of 2 and 11. And what we want to do is find an a value and a q value from the information provided on the graph. First, we can see that the shape of the graph is a smiley graph. That means that the a value would be bigger than 0 or positive. Secondly, q represents either the y-intercept or a vertical shift. And we can see that the y-intercept is equal to plus 3. That allows us to partially complete the equation by replacing q with 3. Next, we will use the x and y values provided by this coordinate given to us. So I'll replace fx with 11 because that represents y, and I'll replace x with a 2 because that represents x. So when I substitute these values, I have 11 is equals to a times 2 squared plus 3. And when I multiply out, I have 4a plus 3 is equal to 11. So if I transpose the 3, I have 11 minus 3, which is equal to 8, equal to 4a. Then I divide both sides by 4 in order to find the a value. So a is equal to 2. And now that I have the a value, I can complete the original equation. Therefore, the equation of this graph is fx is equal to 2, which is the a value, x squared plus 3, which is the y-intercept. In our second example, we are given two x-intercepts and a y-intercept, and we want to find fx equals to ax squared plus q. So again, we want to find the a value and the q value. So as in our previous example, we can read the q value as plus 5 because it is the y-intercept. So we can read it from the graph. Next, we want to know how to use the points of 2 and negative 2. It's important to understand that these are simple coordinates of 2 and 0 and negative 2 and 0. And you can use any one of these 2 points and substitute it in the place of x and y in order for you to find the a value. So I'm going to use this x-intercept on the right. So y I would replace with 0 because we're on the x-axis, and on the x-axis y is equals to 0 everywhere, and that is equals to a times 2 squared plus 5. So if I multiply out, I have 0 equals to 4a plus 5. Transposing the 5, I have negative 5 equals to 4a, and then finally dividing by 4, I have negative 5 over 4 as my a value. Therefore, the equation of the graph is fx is equals to negative 5 over 4 x squared plus 5.